Hello, I'm Christopher Mohalley, Training Manager for Regal Beloit. In our introduction to the Evergreen IM video, we covered the features and the benefits of this innovative product. Today we're going to talk about applications and ratings, motor mounts, electrical connections, operational characteristics and features, and industry best practices related to motor replacement and airflow measurements. Now it's time to talk about installing it into your HVAC system. Let's get started. Let's talk about applications and ratings. The Evergreen IM is designed to replace PSC motors in residential and light commercial HVAC systems. Specifically PSC motors that say 1075 RPM on their rating plate. The Evergreen IM is not designed to replace OEM ECM indoor blower motors, such as the X13 24-volt multi-tap motor, or the Model 3.0 communicating 4-pin motor, or the Model Eon 16-pin communicating motor. These two communicating motors are often referred to as variable speed. The Evergreen IM is built in two versatile sizes. The 1/2 horsepower motor can replace 1/5, 1/4, 1/3, and 1/2 horsepower PSC sizes. Its stock number is 6005. The 1 horsepower motor can replace 1/2 horsepower, 3/4, or 1 horsepower PSC motors, and its stock number is 6010. Both motors are dual rotation, and that's automatic dual rotation. Both motors are also dual voltage. They can be operated at either 120 or 230 volts AC. These motors are rated for 1070 RPM to match the PSC motor they're designed to replace. They are direct drive motors with 48 NEMA frames, meaning their frame size is 5.6 inches in diameter. They have a 5-inch shaft with a 1/2-inch shaft diameter. Both motors come with permanently lubricated ball bearings, and all Evergreen come with a 2-year warranty. Motor dimensions and full specifications can be found on our website, thedealertoolbox.com. With two multi-horsepower products, selecting the correct replacement motor is very easy. If your old motor is 1/5 through 1/3 horsepower rated, you're obviously going to use the 1/2 horsepower motor. If your old motor is 3/4 or 1 horsepower rated, you're obviously going to use the 1 horsepower motor. If your old motor is 1/2 horsepower rated, you could actually use the 1/2 or 1 horsepower motor. To help you get the right motor for your application, we provide a selection guide in the installation manual. The selection guide is going to tell you that if you have a 1.5 to 3 ton air conditioner and or a 40,000 to 95,000 BTU furnace, you would select the 1/2 horsepower motor. It's going to go on to say if you have a 3.5 to 5 ton air conditioner, or if you have a 100,000 to 150,000 BTU furnace, you would use the 1 horsepower motor. Selecting the correct motor for your 1/2 horsepower needs makes sure that you don't spend more money than you need to on the larger motor, and that you're not trying to put a longer motor in a smaller application. The Evergreen IM is a NEMA 48 frame motor, meaning that it's approximately 5.6 inches in diameter. If your existing PSC motor is also a NEMA 48 frame motor, and it's installed in a belly band style mount, you can simply loosen the bolt on the mount, take out your PSC motor, and slide in the Evergreen. If your existing PSC motor is not a NEMA 48 frame mount, or the mount is welded to, bolted to, or connected around the bearing portion of the PSC motor, you are going to need a new universal replacement motor mount. Any universal motor mount that you use is going to have to match two criteria. One, it's obviously going to need to fit a NEMA 48 frame motor, so it's going to have to be a 5.6 inch diameter frame. The easiest way to make sure you have the right bolt hole diameter is to simply measure the air opening around the motor. That's the dimension between here and here. Take that dimension and add an inch to it, and you have the minimum distance or minimum diameter of the bolt circle required for your motor mount to reach the sheet metal of your blower section. As a side note, we do not recommend using the torsion flex mount on the 1 horsepower motor. However, it is okay to use it on the 1/2 horsepower product. After you've selected the motor mount for your job, it's time to install it on the motor. It's unlikely that the bolt holes of the new motor mount are going to match the bolt hole locations of the existing motor mount. In that case, you're going to have to drill new holes, and I strongly recommend not using just a sheet metal screw, but using an actual bolt and a nut, which our motor kits do provide. This makes sure that we get a secure long-term installation. We want to make sure to locate the motor mount between the vent holes in the shell and these dimples. These dimples locate the bottom of the stator stack, meaning that below the dimples is the open area in the motor shell where the electronics portion of the motor exists. So we want to keep the motor mount between the dimples and the motor vents, of course not covering the motor vents. Last but not least, to orient the motor in the motor mount, we want to imagine how that motor is going to sit when it exists in the HVAC system. We want it to exist so that the connectors are facing down or between the 4 and 8 o'clock position. That way, if any water gets on the motor shell or the motor harness, it rolls off instead of running into the electrical connections. And last but not least, our industry best practices tell us to center the blower wheel in the housing and then tighten the hub bolt on the flat part of the shaft. Let's talk about electrical connections. But before we begin, let's look at what comes in the box with the Evergreen IM. Of course, the installation manual. Being a dual voltage motor, we have jumper pins, one for 115 volt and one for 208, 230 volt applications. What I would consider a required sticker or label to install in the HVAC system, some optional wires and connectors, depending on how you are going to configure the system, and the main harness that connects the Evergreen IM to the HVAC system. Let's begin by connecting the main harness to the motor. Before we connect the harness to the motor, it's a good idea to select the voltage jumper that we're going to be using. The white jumper is used for 115 volt systems. The yellow jumper is used for 208, 230 volt systems. They are also stamped on the jumper so that you don't need to reference the manual for this information. I'm going to select the 115 volt jumper. Again, I strongly recommend you put the jumper in the motor first and then connect the 2 harness plugs. After I get the 2 harness plugs into the Evergreen IM motor, you now see why it's a good idea to put that voltage jumper in first. Now we have 42 inches worth of leads to connect the Evergreen IM to our HVAC system. At the other end of the Evergreen IM harness, we basically have 3 mini harnesses. Each mini harness is taped and flagged with information telling you what to do with these wires. So let's overview that real quick. The high voltage power harness will connect to the incoming power supply to the HVAC system. The high voltage signal harness will connect to the fan relays that used to turn on the PSC motor speed taps. And the low voltage signal harness will connect to the thermostat connections to select the speeds for each mode of operation. Let's see how that works on the HVAC system. So this could be any HVAC system with a PSC motor. It could be heating only, heating and cooling. This one happens to be a heating and cooling system, and it happens to have a circuit board. You can connect the Evergreen IM to systems that do not have circuit boards and simply have fan relays, but we're going to go through it here on the circuit board. I'm going to start with the high voltage power connections. That's the black and white connections. And you'll notice that the white wire already has a female 1/4 inch spade terminal on it, and the black L1 wire already has a 1/4 inch spade terminal on it with a male piggyback. So here we have our PSC motor connected to the board. We're going to disconnect the neutral wire from the PSC motor to the board, and we're going to take the neutral wire from the Evergreen IM harness and put it right back on the same terminal. Now we need the line 1 voltage input to that board. That terminal is not just going to be empty and waiting for you to put a wire on. So we're going to look for the line voltage wire coming from the main disconnect to the board or the line voltage wire coming from the door switch to the board. We're going to disconnect that terminal. We're going to put it on the back of the piggyback, and we're going to connect that right back where it was. Oop, right back where it was. There we go. So if you notice, those two wires had 1/4-inch spade terminals on them. The line 1 wire had the piggyback on. So that really makes this whole process about 30 seconds, and we're 1/3 of the way through the installation of our wiring. The only change we would make if this were a 230-volt air handler, package system, or furnace is our white wire, instead of connecting to a neutral tap, would actually be connecting to the L2 line of the HVAC system power supply. Next, we're going to talk about connecting the high voltage signal wires to the HVAC system. You'll notice that they come prepared with a 1/4-inch female spade terminal on both wires and 1/4-inch Y adapters. This is going to make connecting these two wires to your HVAC system quick and easy. So the first thing we're going to do is go to the HVAC control board, find our speeds from our PSC motor, and disconnect them from the heat taps, the cool taps, and the continuous fan tap, if applicable. Next, we need to determine, do we need both of these wires or just one of them? For that, we're going to go to the label on the motor or the installation manual for our horsepower selection guide. You see, these wires don't just tell the motor when to turn on, they also select the horsepower from its multi-horsepower capability. If I want, for example, the 1/2 horse motor to run at 1/4 horsepower, I would use the red wire only. If I want the 1/2 horsepower motor to run at 1/3 horsepower, I would use the black wire only. And if I want that 1/2 horsepower motor to run at a full 1/2 horsepower, I would connect both the red and the black wires to those speed taps. So let's say we're going to use this 1/2 horsepower motor as a 1/2 horsepower motor. So the first thing we're going to do is get our jumper wire out of our box of parts, and we're going to put it to 1 wire on the 1/4-inch Y connector, jumper that over to the other 1/4-inch Y connector, and then I'm simply going to connect these two terminals to the heat and cool taps on my system control board. What that's going to do is it's going to make sure that regardless of whether there was a heat call or a cool call, that I run both the black and the red wires for my on command and my horsepower selection. So if you haven't noticed, we've already disconnected all of the wires off of our PSC motor, and we've already connected 2 of the 3 harnesses. The last harness is what we call the low voltage signal harness. These are actually the speed taps of the Evergreen IM motor. The blue wire is a 24 volt common wire. The other 4 wires are our 24 volt speed taps. And we're going to connect those to the thermostat connections to make sure we have whatever speed we want match the demand. So for example, the blue wire would go to our thermostat common. If I wanted low speed for heat, I would connect the white wire to the heat terminal, which is usually labeled W. And if I wanted high speed for cool, I would connect this yellow wire to the cooling wire, which is usually labeled Y. When I'm all done, I would then tape off my other 2 unused speeds. So before we wrap up the electrical connections, let's talk about a couple of what-if scenarios. Because every system you work on isn't going to be a heating and cooling only system with just heat and cool taps on the control board. So what if there is a continuous fan tap on the control board next to heat and cool? We would need to connect that continuous fan terminal together with the heat and cool terminals so that when the customer turns on the continuous fan setting on their thermostat, they turn on the motor and select the right horsepower. If you remember, in the box we have extra jumper wires and extra 1/4-inch terminal Y connectors. So these extra terminals and wires are going to allow us to jumper in that continuous fan tap if needed. So another what if that you might find is a 2-stage furnace or a 2-stage air conditioner. In that application, you're going to have either a low heat and a high heat or a low cool and a high cool terminal on your control board. So for example, if you had a 2-stage furnace with a single-stage air conditioner, you would have a low heat, a high heat, and a cool terminal. Again, back to the extra parts, we would need to jumper low heat, high heat, and cool all together using the parts that came with the Evergreen IM. And so far, hopefully you've noticed, this would be pretty easy to do with all of the parts we've given you to connect these wires to the HVAC system. In that multi-stage scenario that we just talked about, it was also going to be necessary to connect a speed to both low heat and high heat, or both low cool and high cool, which is fine because you have 4 speeds to choose from. Something I didn't talk about earlier, if you notice, our speed connections are bare wire stripped. The reason why we left these wires bare wire strip is because if you look at the thermostat connections on most control boards, they're little screws and they're very close together. So we wanted to put either a fork terminal or an eyelet terminal on these wires, but we found that in most cases you're probably going to end up cutting it off because it's not going to fit under those terminals. So we left these wires bare wire strip, and I actually recommend from my installations that I have done in my own home or for my family that you leave the wires that are already under those terminals there, come back about 6 inches, and wire nut these wires into the wire that you want it to be connected to. Because it's going to be very common that the wires that we're using and the wires that are already under those terminals could be a different gauge and a different design. Our wires are stranded, and the wires that are under those terminals are quite often solid core. Mixing these wires under one terminal could cause one wire to be looser than the other and cause a future failure for the HVAC system. The last scenario would be simply to talk about what if you don't need the 1/2 horsepower motor to run at 1/2 horse. You would then either use your red wire for the 1/4 horse application or your black wire for the 1/3 horsepower application. Let's say I needed to use the red wire only, because either one, right? I would take the jumper, connect it to the red wire, and put those 2 wires on my heat and cool terminals. Could have just as easily done that with the black wire. So what this means is it's probably going to take just as long to connect these connections to the HVAC system as it is to open up the manual and look at the chart and determine which horsepower you need and how you're going to configure them with a jumper wire. Let's talk about operational characteristics and features. If you remember, we mentioned that the Evergreen IM is a dual rotation motor. The first time it turns on, it's going to run both directions to automatically configure itself to the rotation of the blower wheel in your HVAC system. So let's look at how that works. On the first demand call to the motor is going to turn on, and it's going to run clockwise for about 10 to 15 seconds at a very slow RPM. Then it's going to do something that's going to weird you out. It's going to shut off. It's shutting off so that it can reverse and run the opposite direction for another 10 to 15 seconds at that very low RPM. What the microprocessor is doing is running the wheel at the same RPMs in both directions, measuring the current or the power, and determining which direction takes the most power to run the blower wheel. So if the motor actually needs to run clockwise, it's going to stop one more time and then turn on to the counterclockwise direction, running at whatever demand you've got turned on in the HVAC system. Also keep in mind that it will only run this rotation sensing sequence the first time the motor's turned on. Every consecutive start, the motor will simply turn on and run the direction that it's already automatically configured to. If you decide to use the motor somewhere else and need the motor to run a different rotation, you can always reset this function, putting the motor back to its factory out-of-box condition using the directions in the back of the installation manual. So even though we've connected wires to this control board in a different configuration than the way the PSC motor was connected, we've still maintained the sequence of operation in the HVAC system due to the way that we've designed the Evergreen IM to operate. So when the thermostat sends a demand call down to the control board, it is going to turn on one of the speed taps. However, the speed taps are not an on command to the microprocessor. If you remember, we talked about the on command comes from those high voltage signal inputs that are connected to the fan relays. So the way any demand call will go is the thermostat will send a demand down to the control board. That will energize a speed tap, but the motor won't turn on until one of the fan relays is energized. So if the control board or separate components have on and off delays or even selectable or adjustable on and off delays, all of these delays and all of the sequence of operation in the system, the way the manufacturer designed it, are still applicable to the way we've connected the Evergreen IM. The continuous fan operation is one more thing I like to talk about because, well, really it's one of the biggest features of the Evergreen IM. If you remember when we talked about connecting the thermostat wires to the speed taps of the Evergreen motor, we did not talk about connecting any speed taps from the motor to the G terminal on the board. The G terminal is what's energized when a thermostat is set to the continuous fan mode operation. The reason we don't suggest connecting any speed taps to G is that the horsepower wires, or what we call the high voltage signal wires, when they're energized alone, the motor knows to turn on. It just doesn't have a speed energized to associate with that on command. So what we've done with the Evergreen IM is we've programmed it that if only the horsepower or the high voltage signal wires are energized and all of the speed taps are turned off, it automatically runs its 600 RPM, super low, super efficient, super quiet continuous fan speed. So you give the customer the quietest and most efficient continuous fan without connecting any wires at all. However, if you wanted to give your customer more continuous air ventilation, you could connect any motor speed that's not being used to the G terminal, which is probably going to be favorable to the bigger homes or customers that count on their indoor air quality products 24 hours a day. Now that we've completed all of our wiring connections and you understand completely how the Evergreen IM operates, the last step in the process is to run our HVAC system in all modes of operation, measure our airflow, and adjust the speeds and/or horsepower that we've set up for the proper operation of our HVAC system, which is an industry best practice after replacing any motor, whether it be universal or OEM. Last but not least, I highly recommend that you take the sticker or decal out of the bag and put it on the HVAC system next to the schematic, so it identifies for the next contractor the speeds, the horsepower, and the wiring for the Evergreen IM that's been connected in their HVAC system. And it also gives them the 800 technical support number if needed. Everything we just covered can be found in the installation manual that's included with all Evergreen IM motors and can be found on our website, thedealertoolbox.com. In addition, we've moved all of the charts that we discussed to the back of the book for a quick reference guide. The motor selection chart, the horsepower selection chart, some worksheets, and even some airflow charts and some notes areas if needed. In the manual, as well as on the ID label, as well as on the motor label, is the schematic for the entire motor harness. This should make installing Evergreen IM very easy. And last but not least, should you need any diagnostic support, there's 3 pages of diagnostic guides in the back of the manual and our 800 tech support number on the back cover. Evergreen IM makes replacing or upgrading PSC systems with ECM comfort and efficiency easy. 2 versatile multi-horsepower, dual voltage, dual rotation motors reduce your truck stock. For more information on Evergreen applications and installation, check out the rest of our Evergreen video series.